So section 3.4 is the sum and difference formulas, some of the last things you are going to have to memorize. And what we're going to do with them is to use sum and difference formulas to find exact values. And then we're going to use sum and difference formulas to establish identities. And then use sum and difference formulas involving inverse trig functions. So there's a pattern to these formulas. So they do need to be memorized. So use whatever memorization tools you're finding effective. And you do need to remember that there's alpha and beta, or you can call them A and B if you like. And then there's a pattern for the formulas. So it goes sine, cosine, cosine, sine, cosine, cosine, sine, sine, plus, minus, minus, plus. So we can actually write these formulas smaller by writing sine of alpha plus or minus beta and saying, oh, that's sine alpha cosine beta. When it's the plus in the argument, it's the plus on the right. When it's the minus in the argument, it's the minus on the right. And then it's cosine alpha sine beta. So this kind of just is a more compact way for memorizing it. Sine, cosine, cosine, sine. Then the cosine of a sum or difference is cosine, cosine, sine, sine, alpha, beta, alpha, beta. But now for cosine, if it's plus in the argument, it's minus in the formula. And if it's minus in the argument, it's plus in the formula. So I remember it as sine, cosine, cosine, sine, cosine, cosine, sine, sine, plus, minus, minus, plus. So work on memorizing those. And these are theorems. And so know that there's proofs for all these theorems. They are in your book. We're not going to take the time to go through the proofs because in trigonometry we focus more on using the tools. But know that later in math you're very likely to need to be able to prove these theorems. So the first objective is to use the sum and difference formulas to find exact values. So the sine or cosine of any angle that can be written as a sum or difference of angles whose sines and cosines we know can be found using this formula. So the idea would be for finding the sine of pi over 12, you'd try and think of some way to write pi over 12 as an alpha plus a beta or an alpha minus a beta, where the alpha and the beta are one of our special angles. So 0 is not going to be that useful, but pi over 6, pi over 4, pi over 3, pi over 2, those are our special angles. So if you turn them all into 12ths, that might be the easiest way to see what combination might work. And actually, there's more than one way to do this. So you can see that if you do pi over 3 minus pi over 4, that would work. Or if you do pi over 4 minus pi over 6, that would work. So in class, we'll work on plugging everything into the formula and evaluating it. Let's do one of these together here. So let's write this as the sine of pi over 3 minus pi over 4. So the formula goes sine, cosine, cosine, sine. First angle, second angle, first angle, second angle. When there's a minus in the argument. There's a minus in the formula when it's the sine function. And now we can evaluate this. So we say, let's see, sine pi over 3 is root 3 over 2. Cosine pi over 4 is root 2 over 2. Cosine pi over 3 is a half. And sine pi over 4 is root 2 over 2. So you can get root 6 over 4 minus root 2 over 4, and you can write that over the same denominator if you like. So that's going to be our answer. So that's an exact answer. So another way this theorem can be used is if you recognize the pattern. So you see, oh, sine, cosine, cosine, sine, angle 1, angle 2. Oh, this is the pattern sine of first angle minus the second angle. So look for that pattern. See, oh, that's the sine of negative 60 degrees. But then we know that that's the opposite of sine 60 degrees since the sine function is odd. And the sine of 60 degrees is root 3 over 2. So this is negative root 3 over 2. And I'll let you look at the next one. So here's some with radians. So you can look at those also. So next we're going to use the sum and difference formulas to establish identities. So we already know from looking at the graphs that if we do the cosine of pi over 2 minus theta, cosine is even, so that's the same thing as the cosine of theta minus pi over 2, because that's the opposite of the argument. And we know that this means the graph has shifted pi over 2 to the right. Well, sure enough, we've noticed already that if I take the cosine graph and shift it pi over 2 to the right, then it looks exactly like the sine graph. So this is the algebraic way of saying the same thing. So we can use the difference formula with alpha being pi over 2 and beta being theta. And you'll see that you're going to get cosine, cosine, sine, sine, first angle, second angle, second angle. And with the cosine, when you have a minus in the argument, you get a plus in the formula. But we know that the cosine of pi over 2 is 0. So we're going to get cosine theta plus, times 0, plus sine of pi over 2 is 1 times sine theta. So all we have left is sine theta. So these are the same as the theorem that says co-functions of complementary angles are equal. So there's more than one way to get to a lot of things in trig. So then we have formulas for the sum and difference for the tangent. So some people use rhythm again for this and they say tan, tan over 1 tan, tan. And then it's plus, plus, minus, 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 plus. So if you want to put them together and say the tan of alpha plus or minus beta, you see you get a tangent alpha and a tangent beta. So look for patterns. Patterns help your brain memorize. And you get a 1 and a tangent alpha and a tangent beta. When there's a plus, you get a plus and a minus. And when there's a minus, you get a minus and a plus. So that's the formula in one formula instead of two separate ones. So again, the idea would be to take 19 pi over 12, and let's see, that one's a bigger angle, so this is probably going to be an alpha plus a beta. And in fact, if you think about it, 12 pi over 12 is pi. So you could think of this as pi plus 7 pi over 12. And go from there. So we'll look at these together in class. And then number 26 is one of recognizing the pattern. And see, this is the pattern where alpha is 40 degrees, beta is 10 degrees, and I have a minus in the top and a plus in the bottom. So that's the tangent of 40 degrees minus 10 degrees because it matches that pattern. So it's the tangent of 30 degrees. So this is going to be root 3 over 3. Okay, so your homework problems are going to take a while because they're going to have 4 parts to them. Find the sign of the sum, sign of the difference, cosine of the sum, and tangent of the difference, given some information. So this first problem, they're giving you the cosine of alpha, and they're telling you what quadrant it's in. So this angle alpha has a cosine of root 5 over 5, and it's in quadrant 1. This is quadrant 1, right? So if it has a cosine of root 5 over 5, then it must have a third side length of 2 root 5. Check and make sure that makes sense. So this is the angle alpha. And then we're told angle beta is in quadrant 4. So I'm going to draw it in quadrant 4. Angle beta has a sine of -4/5. And I'm going to pause here and make another movie because this is not all going to fit on one.